So, like I said, we've built up the basics of all of our volumes: cylinder, cone, sphere. Now we're going to get a little bit more complicated with how we're going to kind of deal with those volumes. So let's take a look. We'll start out nice and simple with the first one. A drinking glass is filled 3/4 of the way up with water, 3/4 of the way up. You guys see that water in the glass right there?
Yeah.
Okay. If the glass is 10 centimeters tall with a radius of 3 centimeters, what is the volume of the water in the glass? Just the volume of the water in the glass. Take a moment, think about how we might be able to solve this problem. Do we know how to find the volume of a cylinder?
Yeah.
Yeah? What's the formula for the volume of a cylinder?
Formula is V equals
Good start. Pi r squared times h.
over 3.
That's a cone. Right, again, we can take a look over there. We could literally flip one page back. Oh, boom, there it is right there. Okay, does anyone not have this paper that we glued in on Thursday?
It's at home.
Okay.
I got it.
Shouldn't be at home. Should be glued into our notebook, right? With the rest of your notes. It's odd. So, what are the two things we need?
Folder for a reason.
Okay, what are the two things we need to know in order to use this formula? We need to know the radius and the height, okay? Does it tell me what the height of this glass is?
No.
If the glass is 10 centimeters tall,
Yeah.
right, just because it's not labeled on the diagram doesn't mean we don't know. And do we know what the radius is? Yeah, 3 centimeters. Right, we see that little half line. I know it's 3 centimeters. So you know what? Let's find the volume of the entire glass first, right? The water is only up to this line right here. All right, this little blue space right here, that's the water in the cup. But we're going to find the volume of the whole glass first because that's what we know how to do. Pi times r, which is 3, squared times h, which is 10. Well, what is 3 squared? 3 times 3, which gives me 9. And what's 9 times 10? 90. So we get 90 pi. Because we're dealing with a real-world context, right? This is kind of like a word problem. We're not just talking about some random cylinder. We're talking about a glass of water. We're going to approximate this, okay? 90 times pi is about 282.74. What are my units on this volume? Centimeters? Cubed. So again, this is the volume of the whole glass. Are we asked to find the volume of the whole glass? No, just the water. What is the volume of the water? Well, how can we now figure out what the volume of just the water is? Any ideas? Well, how full is the glass? Do we know that information? It's 3/4 of the way filled. So if the whole volume is this gross number, the water makes up 3/4 of that gross number. How can we find the volume of the water? We can divide it, or we just multiply it by 3/4. Right? This is the whole glass. If I take the whole glass, 282.74, and I multiply it by 3/4, that's going to give me the volume of the water. The water is 3/4 of this whole glass. Do you guys see? Give me a thumbs up if you see how he came up with that idea, right? So we're not just plugging things in, writing the formula, doing all that. Now we got to think a little bit more outside the box. We got to problem solve. Think critically. It's going to be a little bit challenging. There's a couple problems on the worksheet that are pretty difficult, but I want you guys to struggle through it before you just go, Mr. Church, I don't understand this. Okay? Let's plug that in. How can I write 3/4 as a decimal? 0.75. So we'll do 282.74 times 0.75, and that gives me 212 point what? 0.06. 212.06 centimeters cubed. And that represents the volume of the water. We got to find the whole thing first, then we'll take 3/4 of that. Boom, that's our water. Now, if it had asked, what's the volume of the air at the top of the glass, how might we be able to find that? Exactly. We multiply the original volume by 1/4, because that's how much of this glass is air. I know that's a little bit weird, so take a moment, think about that, let it digest for a second before we move on. What questions can I answer about that? Nothing? You guys feeling tired today? Me too. Me too. I was moving all weekend. I feel like a noodle. I don't even feel like I can walk right now. But we're pushing through. Yeah. Like a cooked noodle. You know, you just throw it against the wall and it sticks. All right. Next one here. Again, we got to think a little bit more outside the box. Here we got a mini basketball kept in a glass cube. Should be displayed on a shelf. If the basketball has a diameter of 8 inches and the volume of the cube is 729 cubic inches, what is the volume of the excess air inside the cube? Interesting. Can you guys picture what this image looks like? I know the printing's not very good. Can you guys picture in your head what that looks like? It's like a glass cube, right? You've all seen a cube before. And there's a basketball on the inside. Okay? So the whole cube itself, what's the volume of the whole cube? Does it tell me?
Nuh-uh.
Read it again.
Yeah, 729 inches cubed.
Yep, the volume of the cube is 729 cubic inches. Do we know the volume of the basketball?
Nuh-uh.
No. Can we find the volume of the basketball?
Yeah.
Absolutely. What it's asking for as an answer is the volume of the air. So inside this cube, Caleb, Kyron, please stop talking. Okay, if I want to find the volume of the air inside the cube, that's the whole cube minus the ball. You guys kind of visualizing what I'm talking about? Because air, even though we don't really see it, we move through it, it does have volume, right? It takes up space. Anything that takes up space is going to have volume. So how might we be able to figure this one out? It's a little bit different than the first one. Any ideas on what you think we can do?
Me?
Go ahead.
We find the volume of the circle and then minus 729 by whatever the volume of the circle is.
Perfect. Let's try it. Zach says, first we got to find the volume of the sphere. I would agree with that. The sphere has a diameter of 8 inches, okay? Let's see. The volume of the sphere is 4 pi r cubed over 3. I know that because I read it in my notes. I flipped the page and looked down. There it was. Okay, what can I plug in for r then if I want to find the volume of this basketball? Am I going to plug in 8? Angelina, what am I going to plug in? 4. Where'd you get 4 from? I don't see a 4 in this problem at all. Good. The diameter is 8. So we got to make sure we're reading 2. If the diameter is 8, what's the radius? 4. So when I plug this in, I get 4 pi times 4 cubed over 3. Right? If you remember when we talked about spheres, we did our steps. We cubed the radius, 4 times 4 times 4. We multiply that number by 4. We divide that number by 3. And then we multiply that number by pi. And that gives me about 268.08 inches cubed. Is that my final answer?
No.
No. What does that number represent again? The volume of the sphere, the volume of the ball. So I know what the cube's volume is. I know what the ball's volume is. How can I find the air around the ball's volume? Subtract. Right? I'm going to take the volume of my cube. So here's what we're going to set up. It's going to be the volume of the cube minus the volume of the sphere. And that's going to give me the volume of the air inside the cube. So first, we'll plug in the volume of the cube. What's my volume of the cube? Does it tell me?
729.
729, good.
Inches cubed.
Yep. We'll leave the units off for now. We'll put them on the answer. What's the volume that we found for the sphere? 268.08. All right, we just plug that in. Let's see. 729 minus 268.08. 460.92. What are my units? Inches cubed.
So I was right.
Is that what you said? 460?
Oh no.
Oh, you
I
said.
was right. I lied.
Yes, yeah. Zach walked us through that. That was his idea. Take the volume of the cube, subtract the volume of the sphere. That gives me the volume of the air inside the cube. Does that kind of make sense how we did that?
A little bit.
A little bit. I know we're tired.
Okay.
Maybe we'll have some questions when we actually get to the work. Maybe. We'll see.
I'll just take a nap.
Let's take a look at the last one. This is kind of like our warm-up, basically. We got a cone on top of a cylinder. So a silo used to hold grain on a farm. Do you guys know what a silo is?
No.
Do you guys know what a silo looks like? No?
No.
Anyone ever been to a farm before?
No.
No? You guys just don't go out to farms?
I don't go to like places like.
That's fair.
Oh yeah. What do we know?
So a silo is one of these big old...
If you get
Yeah.
stuck into those corn thingies, you're cooked.
Yeah, exactly. You don't want to get stuck inside a silo. You will definitely not make it out. Okay. So sometimes silos have like a little dome, like a sphere on the top. Sometimes they have more of a cone, like this one here. See, it's got that.
Oh, I see those in like the little cartoon movies.
Yeah.
Shows.
Yes.
Little kids shows. Yeah, I've been seeing that.
That's right. So it's like a big old cylinder, and on top you see we got a nice cone,
Yeah.
right? And the top of the cone is basically the same radius as the top of the cylinder. Okay, see, boom, this is another good example right here. Looks kind of like a rocket, but it's full of corn and grain and
Oh, that's
farm
what that
stuff.
is filled with?
yeah,
I
they
thought it was
put
just,
corn
like,
in there.
There to be there for decoration. How would you
No, no,
Like, they
it's
put- or it's like
that's a
water.
good guess. It's filled with corn. I'm pretty sure. How do you? You're not supposed to go in there.
Then how does it?
Corn goes in there.
Like you could get like. Yeah, I did.
Yeah, if you get in there and then the corn goes on top, you'll definitely die. But
Yeah, because you sink in. And you're cooked. You can't breathe.
how do you get the corn out? This is a good question. These are all great questions that I unfortunately do not know the answer to because I am not a farmer. This is what the inside looks like, though. Oh, I don't want to go. What is this? It's a whole thing about grains. Okay, here we go. So it's like big storage container. Bro, stop. It's like big old storage containers where they put like dried corn and wheat and stuff like that.
That's how they be making the corn and the bread.
I guess so. But they're huge. I mean, look at these little guys down here. Look at how big
yeah,
these
we would
silos are.
die.
They're giant.
We would die.
Plus, it's like if you get in there, I don't know why we're talking about getting inside of a silo, but it's like quicksand.
For real?
Yeah. Because when you have like corn kernels, it's all solid, but when they're in that big of a volume, it kind of turns into a liquid. It's like have you ever seen DuckTales? Do you know what DuckTales is?
Yeah.
Cartoon where the guy jumps in the pool of coins.
Oh, no.
The duck. You guys know what I'm talking
I know
about?
what you're talking about.
Yeah.
Okay, some of you know what I'm talking about. That would not work, obviously. But if you have enough corn, I feel like that would work. I don't know. Please don't go home and try it. Anyway, so we know what a silo is now. That's good. This one was easier. We all know what a basketball is. Okay. So it's a cylinder with a cone on top based on the diagram below. What's the volume of the grain that can fit inside the silo? Do we have all the information that we need based on this diagram? What are the two pieces of information we need to find volume again? Radius and
diameter.
not the diameter, the height. Radius and the height. So just like our warm-up, we're going to split this into two. There's like two problems that we're going to combine at the end. Let's find first the volume of the cone. Here's the cone on the top. Okay, it's going to be pi r squared h over 3. What's my radius? Or actually, let's start with my height. What's the height of the cone based on this diagram? Yeah, how tall is the cone? Yeah, if we just look at the cone, look at that. It's 9 feet tall. That's what that little line tells me. So my height is 9. You guys see a radius anywhere? No? What do you see, though? The diameter. Right? See how this circle lines up perfectly with this circle? That means they're the same. So if this circle has a diameter of 18, what would the radius be? 9. So what am I going to plug in for r here? 9. Let's see what that comes out to. 9 squared is 81. 81 times 9 is 729. Divided by 3 is 243. Times pi is 763.41 feet cubed. Oops. So once we get the formula set up, at this point we can just plug it all into our calculator and go, go, go. We want an approximate volume anyway. That's just for the little pointy part on the top. Now let's figure out what the volume is for the cylinder on the bottom. What's the radius for my cylinder here? Is it different from my cone's radius? Or is it the same? It's the same. So my radius is still 9. What's the height, though, of the cylinder? 60 feet. It's going to be a big number, but that's okay. Let's see what we get. 9 times 9. 9 times 9 is 81. Times 60 is that. Times pi is 15,268.14. That is a lot of corn or grain. Feet cubed. $15,268.14. I know it's kind of hard to see because I went over the line there, but there's a point 14 there. So I found the volume of the tippy top. I found the volume of the cylinder on the base. But the question's asking, what's the volume of the grain that can fit inside the whole silo? How can I figure that number out? Am I going to subtract like I did in the second example? Or am I going to do something else? Jawad? What's that? The grain goes inside the cone? Yeah, it can get filled all the way up. So you would add, exactly. So in this problem, we're trying to find the air's volume. So we take the big volume minus the little volume, and we get what's left. But here we got to take two little volumes, put them together, make a big volume. Does that make sense? So it just depends on what the question is asking. That's going to tell you what to do. The volume of the whole silo is the volume of the cone plus the volume of the cylinder whereas up here, again, we subtracted. Here, now we're going to add. So the cone's volume was 763.41. The cylinder's volume was 15,268.14. And we'll just add those together using our calculator, thankfully. 15,268.14 plus 763.41. Boom. 16,031.55. What are my units though? Feet cubed. Quick show of thumbs. How's this last one sound? Thumbs up sounds good. Makes a lot of sense. Thumbs sideways kind of seems okay. Maybe a little weird. Okay. I appreciate those of you that are with me. Hopefully that makes some sense.
That's a lot of writing.
So 3 different types, right? We've got one where we're taking a fraction of the overall volume. We've got one where we're subtracting 2 volumes to find the answer. We've got one where we're adding 2 volumes to find the answer. All right? Now with worksheet 56, which we're about to get, luckily the front of this is just regular volume. So we got a basketball with this radius. What's the volume of the air? A can of soup with this diameter and height. What's the volume of soup? So we're not doing any combined volumes or anything on the front. Just doing a couple real world examples. On the back, you're going to see some... It's only 7 questions total.
Oh.
On the back, you'll see there's 2 shapes, right? What 2 shapes do you see on this snow cone?
Cylinder and cone. I mean, not a cylinder. I mean a sphere and a cone.
A sphere on the top and a cone on the bottom. What about this thing of tennis balls here? What do you see there?
A little
Spheres and a
Cylinder.
cylinder. What about this drum of oil?
a cylinder.
Just a cylinder, right? But you'll see that one's kind of like the first example that we did. All right? So again,